While holding the famous chairs of mathematics in Rome, Pavia, and Milan, celebrated scholar von Dubrovnik tackled many problems of pure and applied mathematics. He achieved his most important results in three areas: synthetic geometry, applied mathematics, and foundations of mathematics. In solving a given problem, Boscovich would sometimes use both a geometrical and an infinitesimal method. In making his selection, he would more often make use of geometry, particularly in natural philosophy. Some problems he solved by using both methods at the same time, as for example the problem of body acting with the greatest attractive force on a point of its axis, and on a mathematical description of the cell of the honeycomb, which is shown now. Geophysical topics attracted young Boscovich in the early days of his scientific work. The first two treatises he published as student of theology in 1739. In the treatise, in the treatise De Inequalitate Realitatis in Diversis Spherulotis, on the inequality of gravity at diverse points of the Earth, he warned about the variations in the density of the Earth's crust and the possibility of the existence of great underground cavities, especially those resulting from the elevation of the Earth's crust in the mountain formation. Geodetic measurements along the Roman meridian deepened Boscovich's interest in geophysics. Opusculum quintum of his major geodetic work, De Literaria Expedizione per Pontificia Ambizione, Boscovich devoted entirely to the theoretical considerations on the shape of the Earth. Here, for the first time, he introduced the concept of compensation into geophysical research. The emptiness inside the mountains compensates for the matter that lies over it. It's his quotation. That was the first mention of compensation ever. Inequalities in the distribution of the masses inside the Earth occupied Boscovich's mind continuously. From there stem all his later contributions to geophysics, particularly in his letter to Antonio Valzinieri. Four meteorological phenomena attracted the attention of Boscovich the scientist: the northern light, the rainbow, the whirlwind, and the density of the Earth's atmosphere. In the period from 1738 to 1760, Boscovich wrote and published 10 papers on meteorological topics. He wrote about the aurora borealis, most often 5 times, and about the rainbow 3 times. Boscovich was prompted to his first meteorological research by the aurora borealis that the whole of Europe had observed in the night of 16 to 17 December 1737. And so for the end of that academic year, prepared the treatise De Aurora Boreali, in which he concentrated on methods for determining the distance of the northern lights from the surface of the Earth, as well as the search for the cause of the phenomenon. He accepted Marin's explanation that the northern lights resulted from the movement of substances from the sun's atmosphere, but modified it in accordance with his own astronomical worldview. Out of respect for Carlo Noceti, his professor in the philosophy and theology, in 1747, Boscovich wrote notes to accompany Noceti's poems on the rainbow and the northern lights. Among the notes on the rainbow, the one containing the critical view by which Descartes and Newton were to be credited for the explanation of the rainbow, and not Marco Antonio Dominis should be singled out. Annotating his professor's verses on the basis of a critical comparison of the De Dominis, Descartes, and Newton's writings, he turned into the historian of science. His absorption in meteorological topics also reflected in Boscovich's collaboration with the journal Giornale dei Letterati in 1747 and 1748, when he printed his proof of one problem of Newton optics, he has shown, and 5 dialogues on the Northern Lights. On the night from 11 to 12 June 1749, ferocious whirlwind devastated much of Rome. By order of Cardinal Silvio Valenti, Secretary of State of the Holy See, Boscovich wrote a treatise of the whirlwind, his most extensive meteorological work, in no more than 20 days. In this work, he offered a classification of whirlwinds and deliberated at length on the nature of such a wind. Benjamin Franklin quoted Boscovich but once from his treatise of the Roman whirlwind. Now I will talk about Boscovich's contribution to the technical sciences. Yes. To structural engineering, geodesy and cartography, hydraulic engineering regarding rivers, ports, and marshes, and the fourth, theory, construction, and verification of instruments in astronomy, optics, geodesy, geophysics, and mathematics. At the beginning of his Roman professorship, at the orders of Benedict XIV,